Hello everyone. In our today's lesson, we are going to determine the percentage of hydrogen peroxide H2O2 in a drugstore bottle of hydrogen peroxide. So let's get started. So I'm going to explain how to conduct a titration process of the reaction between commercially available hydrogen peroxide and potassium permanganate. Then determine the concentration of hydrogen peroxide solution. Hydrogen peroxide is easily oxidized. It's used in a commercial bleaching processes and in wastewater treatment plant as an environmentally friendly alternative to chlorine. The dilute solutions of hydrogen peroxide are used to bleach hair and to clean wounds. That's why it's very important to know the actual concentration of a solution of hydrogen peroxide, as its effectiveness can decrease with smaller concentrations. Before we conduct this titration process, potassium permanganate must be standardized with a solution of iron 2 sulfate. This means that its concentration must be determined exactly so that it can be used as a titrant to determine the concentration of the hydrogen peroxide. Potassium permanganate can be standardized in an acidic solution with a known concentration of iron 2 ion Fe2+ to produce manganese 2 ion Mn2+ and iron 3 ions Fe3+. Once the potassium permanganate solution is standardized, it will be then used to titrate the hydrogen peroxide solution in the presence of an acid. In an acidic solution, permanganate ion MnO4- from KMnO4 solution will be reduced to nearly colorless manganese ion Mn2+, and the aqueous solution of hydrogen peroxide H2O2 will be oxidized to form oxygen gas and hydrogen ion. To conduct the titration experiment, the required materials are burette holder, burette, support stand, volumetric flasks, funnel, Erlenmeyer flasks, and filter paper. Now let's have a look at the procedures that must be followed for the titration experiment. Firstly, measure a known volume of hydrogen peroxide solution into the titration flask using a volumetric pipette. Then, fill a clean burette with a 50 ml of the standardized potassium permanganate KMnO4 solution and record the initial burette reading. Then, open the burette tab and let the potassium permanganate flow into the flask, and keep swirling the flask gently to make sure that potassium permanganate and the hydrogen peroxide mix well and react. Keep adding the potassium permanganate solution that has a purple color to the hydrogen peroxide solution slowly to produce colorless manganese 2 ion Mn2+. Thus, the color will fade in the flask when all the hydrogen peroxide has been used up. The last drop of potassium permanganate that is added will keep its color. The end point of the titration is the point at which the last drop of potassium permanganate KMnO4 added to the solution causes it to turn pink. Then, record the final burette reading to determine the volume of potassium permanganate needed to reach the equivalence point, or the volume at which a pale pink end point occurs. Finally, repeat the necessary steps at least 3 times and analyze the titration curve of your trials to precisely determine the equivalence point of the reaction. That was the end of our lesson today. Now we know how to practically determine the concentration of hydrogen peroxide in a commercial product. Thank you for listening and see you in the next video.